Hello?
Hey, can you see me? It's early this morning, isn't it? Seems like it. Am I getting used to being at home, just wanting to sleep? Hey, Isaiah.
It does seem rather early this morning.
Doesn't it? I guess it's been a long week. I don't know about for you guys, but it's been a hard week for me. Just really busy this week, it seems like. So I think it might have something to do with Adam.
You still recognize weeks?
Just going by days, or are you down to hours, minutes?
It's just one long day.
It's just never ending, huh? Now, since my husband is still going to work, we have to keep track of days. We don't want him to go if he doesn't have to. But luckily, his job, he doesn't run into a lot of people. So hopefully it'll be okay. Did anybody find any cool stuff in Adam, or already know cool stuff in Adam that you want to share? Anything fun?
Didn't find anything.
You wait.
I didn't find anything.
Nothing good, huh? There's some good stuff. We'll look and see if we can find any. But I think some of it is stuff that we learn about as we go. So we'll look. I'm going to share my screen and turn this off. Silly video. We'll look at some code here in a minute. But we had stopped last time talking about subprograms, and we've been using functions. And for the first time, we set up a script that called a function and passed some data. So our function imported that data as input. If I look at this program, that we did the yellow duck one. I don't know why it's not color coding it in Atom. So we have to kind of look closely. But when we call our function that we created, we have to pass it the data that it's asked for. So in my call, if I didn't pass, let's see, when I declare the function, I say I need 2 data items. I'm going to refer to those 2 data items using local variable names, color, and beast. So when we call our animal function, we have to pass those 2 data items or we won't have a successful call. And we saw last time we have to pass them in order, but we do also have to have them. So if I get rid of my type and try to run, I'm going to get an error that I was missing a positional argument. So it is looking at these parameters by position, the first one, the second one. Now, what's separating those positions? There we go. It's a comma. So when I call my function, I use a comma to separate my parameters. And when I declare my function, I use a comma to separate my parameters. Hang on, turn everything on here. So we've seen that when we want to call a function, if that function requires data to import, we have to pass that data as arguments. Now here's an example of a little subprogram, and this is in pseudocode, but you guys are gonna, when you look at it, you might see Python, and that's okay because you've been really focused on Python. But if you look really closely, you'll see it has write statements instead of our Python print statements. But now you're probably starting to see how they are so similar. You have to really look closely to differentiate between the two. So in this example, we have a subprogram, a little function here named exam. It wants 2 parameters, the time of the exam and the room number of the exam. And it takes those data elements and writes out a reminder saying what time and what room number the exam will be in. In this first example, when we call the exam function, we're passing in a value of 9 and 3. So our first position has 9, our second position has 3. So our output would say, your history final will be at 9 o'clock in room number 3. Now, if we called that same function and switched the position of our parameters, our output would be, your history final will be at 3 o'clock in room number 9. So we don't know here which one is correct. Apparently, according to the little emoticons here, this one must be the correct one because he found his exam. But it's important that we make sure things are in the right position. So why do this? We talked a little bit about it last time. Our global variables make all of our functions interdependent. They're too intertwined. We can't separate them out to make them stand alone to do their own function. We want our subprograms to be independent and to stand alone. So when we use arguments and parameters, we can make them be their own little black box that takes data in and in some cases spits some information out so that we can get our functionality going. So they say we're going to use them to enhance the usefulness of subprograms. We could use a function in many different programs if we wanted to. That's called a user-defined function. And so far we've been using some system functions within like the math library. Those started out as probably user-defined functions until they were rolled up into the math library and published for us as system functions that are available to us. Now, when we look at using subprograms, Only the structure of the subprogram is important. How do we call it? We don't care what variable names it uses for that data or anything about it. So these separate, completely separate standalone functions make it easier for us to work as different programmers, so we can each code different functions, and then we can put it all together to make it work. We can also test and debug each function independently of all of the others, so that can make our testing easier. Whenever we declare a function in Python, all we need to do is specify the variable name we want that positional data to assume within our function. In some programming languages, we have to add additional data. So this is an example of declaring a function, a subprogram, within a programming language that requires that. So it's a little different than Python. In some programming languages, we can't just specify the variable name. We have to also specify what data type the variable will be. So in this example, I'm saying this subroutine or function requires a string that I'm going to call var1. It requires an integer that I'm going to call var2, and it requires a float that I'm going to call var3. So this type of function header or subprogram header is real common. It's what you'll see in C# and Java and some other programming languages. So if you see something like that, you know, that's not what Python requires, but it is a common requirement. Okay, this subprogram does a little bit of the, you know, plaque type thing like we did or we're wanting to do in our, whoops, there we go. All right, so it does this sort of plaque thing where it surrounds a word with stars. This one's a little different. It just puts some asterisks before the words and after the words. So let's take a look at it. Here's our main. We start out declaring a variable named message. Then we write out a prompt to enter a short message or sentence to our user, and they type something in. Then we call our subprogram, passing in as an argument that message data that the user supplied. Our subprogram says, oh, I was expecting a string. I'm going to call that string words. So this message variable now becomes data that is stored in a variable named words for this subprogram. And the subprogram writes out the stars, the words, and more stars. So our variable name can change. And that's one of those things I'll keep harping on, and I'll say it and I'll say it. And learning is a process, and there will still be people that are not seeing that until later, and that's okay. Just try to help the people that are in your study group understand that this message variable becomes, the data actually becomes available in this words variable. Now, we can pass data two ways, by value and by reference. When I do a call to a subprogram, the data been saying is passed or imported by the subprogram. We also could send data back. That data would be returned or exported to the calling program. Whenever we're calling things like that, we can't tell how data is flowing by looking at the arguments and parameters. We have to actually look at the logic in the code and see for sure what's going on. Okay, so value and reference parameters, that little side note there, we'll get back to it. Whenever I declare a variable and I pass it to a subprogram, my subprogram is going to receive a copy of that variable. So now that variable data is going to be in memory twice. That value will be retained in memory once for the original program and once for the calling program. whenever our subprogram runs, no matter what it does to the variable, those updates will not be reflected in the calling program's variable. So let's see if we can write a little program to see how that works. I want to go to, instead of using Atom to write this program, open a web browser if you would, and let's go to that Python tutor site, because I think if we visualize running this code, we might be able to understand the passing by value and passing by reference a little better. So I'm here at the Python tutor site, and I want to get some code going here. So I think it's going to let me type. There we go. I'll start off by defining a function. And we can do one that's similar to the one that they had as far as passing the time. Let's call our function meeting. And we'll say that we need data for the time of the meeting and the room of the meeting, just like they did. Now, when we're using this visualizer editor, it's not very good, but it's not too bad. It's a lot like idle. It might actually be idle behind the scenes there because it's very similar. So it won't be as fancy as Atom. We'll get to Atom eventually, but let's take a look at using this for this program. We want to print out, oh, I think we want to create one more variable here. I'm going to call it hold time. And we'll just say we're going to save our variable time. I'm going to print out meeting at, let's use those %d placeholders since I'm not very good at using them. We better get some practice. Meeting at whatever in room %d, and then we close our parentheses, put the %sign, and then in the parentheses we say the positional parameters are time and room. Now I want to test this before we go any further. So we'll just call meeting, and we'll say it is at 9 in room 4. I'm going to try to run that. Line 3. Does it not let us do the % output? Let me check unsupported features. Too large. Too many variables. Is that, it doesn't say it shouldn't be able to do it. Did I forget to close the quote? I did. Good debugger. Very, very good. Thank you. Okay, try again. It still doesn't like it. Oh, that's just my previous error, maybe? Please help us. Now, this is the Python tutor site just asking me if the site helped fix the problem or not. They're just trying to get feedback. So I'm going to click close. And then I'm going to try to run this program. When I start, First, Python will read all the code so that it knows about any subprograms or functions we've declared. And it did find one. It found a function named meeting. So it says, well, I have this function named meeting that requires the time and the room number. So it has that information set there about that function. We're going to call that function. So we set up our call right here. And they just try to show it to us in any way that they can, which is very nice. It's saying, oh, we're going to call this. If I click next, we should save our time in a new variable. There's that. Print out our message. It doesn't like my % things. I'll get rid of them. And then we should be done. But so we're getting some sort of message. I want to edit this code some more. And I'll just fix this to not use those positionals and say, close my string. And then I'll just delete this stuff here. I think I still need one more closing parenthesis. Make sure everything's lined up. So open parenthesis, close parenthesis, string meeting at, and then I'm going to add time as a string, and then I'm going to add in room surrounded by spaces, and then I'm going to add room converted to a string. So this site should like that better, apparently. And I could be using not quite the right syntax on the % output. I don't use it often. So what I really wanted to show you, though, was that if I update these variables, the time and room variables, within our meeting function, it shouldn't affect anything down here. Let's fix this down here so that it's more obvious. I want var1, because I'm a programmer who doesn't like to give things good names, and var2. I'm going to use these variables and set them to these numeric values. And then when I call, I can use these variables. Now, when I call meeting, the data in var1 is going to be copied to the time variable, and the data in var2 is going to be copied to the room variable. So I'm going to try running that. Still mad at me. I thought I took all that out. Did I do it badly? Everything's there now. I'm sorry, it's looking at the last execution. So again, I'm going to let it scan my function. It's going to set up my variables. And now we're ready to call our meeting function. So notice how we have our variables up here, var1 and var2, and then we made a copy of them to pass to our meeting function. That's a really important concept. So if you can get an idea of what's going on there, these are new variables, and that is passing by value. We took the value, we copied it to a new variable that has the same value. I'm going to keep nexting here. And we can see that we're getting a new variable down here in sort of our main. And then we're done. So I want to edit one more time. Because we passed by value, if I update the time variable in this function, say we're 5 hours away from them, and then we're going to print out And I'm just going to change this to say updated. So now I'm going to print out two messages from our meeting function. Our first message is going to be the original time and room, and our second message is going to be the updated time. We see that it's seen our function declaration. We are ready to call our meeting function. We're passing in the values 9 and 4. We're going to print out our first message, meeting at 9 in room 4. Now we're going to update our time variable. Notice that var1 was unaffected, right? When we started out, they had the same contents as each other. But in our function, since we updated our time variable, we see that update here in the local variables for this function, but it had no effect on our calling program. I'm going to click next so we see that message out, that we've got that updated time variable. So that, again, is passing by value. Passing by reference is really hard to show with Python. Python doesn't pass by reference. It's just like, no, don't do it. Now, Python will pass lists and arrays by reference. So when we get to our array section, we could take a look then and see how the difference, how it works. What's happening is if we pass by reference, we're saying, I have this memory location that contains data. When I call a subprogram, I'm just passing that memory location, and that subprogram is going to work on the exact same instance of the variable. So here we see passing by value, the value got copied to a new variable. If this was a pass by reference, var2 and room would be the same variable. There would not be a different variable for within the function. That's passing by reference. The reference is the location in memory where that variable exists. Okay, does that make sense? It's a kind of an obscure concept, but it makes a difference in how you code things and how much memory is used by your application. So within Python, we'll be passing by value. Here's an example. Passing by val and passing by reference. In this pseudocode, they've added some information that, again, some programming languages allow. The pseudocode here is saying that the subprogram switch it is going to require input of an integer that it's going to refer to as number 1, and input of an integer is it's going to refer to as number 2. But the second variable is going to be passed as reference. So this extra keyword says, I want to use the same memory location as the data that is passed to me so that I can update it. Okay, so when we are within our subprogram, we update each of those variables' contents. When we return to our main after calling our switchIt function, we write out both variables' contents. In this case, the first one, my number, would not be updated. It's going to be the original 156. But the second one, your number, because it was passed by reference, will be updated. It'll show the new updated value. It's one of those kinds of things that happens behind the scenes for us as programmers that it's best to try to get an understanding of, even though it's kind of a concept that we can't really get our hands on perfectly well. But I think that visualizer code helps us. I'm going to bring that back up and make sure everybody got that copied. before we move on. I don't think it'll let me expand it much. Zoom in a little bit. So you can save this Python code if you like, just as another example. But not too complicated. The concept is what's fun. Okay, so whenever we create functions, they're user-defined functions. We're the user, we define the functions, they're user-defined. System functions are functions that are available from the system. And most programming languages offer some system functions to do some common things. So here are some common ones. Often we can find functions that convert string data to uppercase or to lowercase. That can be handy. In this example, we're asking the user to enter a Y when they're done with a process. We read in their response, and we can actually use the toUpper function within our conditional to say, take that response and turn it uppercase, and then check it to see if it's an uppercase Y, and then we don't have to worry about uppercase versus lowercase. So that's handy. This thing sort of jumps around a little bit. Sorry about that, but it is giving you a lot of information, so it's kind of jumpy. This narrative here, we want to talk about being really, really careful when we're passing variables around, making sure that we have things in the right order, the right position. In this example, I want you to think about what can happen if something goes awry. Natalie and Nicholas are co-presidents of the Gamers at College Club. They've created a website and they want the site to be secure. Nick suggests that each member should have a secret login name, and Natalie offers to write a program to achieve this. Unfortunately, Natalie did not study this chapter carefully and doesn't understand the difference between value parameters and reference parameters. She writes the pseudocode shown in the next 2 slides. First, in her main, she declares 3 variables that are strings, and she outputs a prompt, "Do you want to start?" asking for a yes or no response. They enter their response, and then she sets it all to lowercase, and then goes into a loop while the response is yes. Within the while loop, we ask for a member's first name, and we read it into the variable first, last name in a variable last, and then we call this function secret login, passing the first name and the last name. We write out a message when it comes back saying the member name is the first name and last name, and then we ask if they would like to enter another. We read the response. This line of code is redundant, right? We don't need it because right up here in our while, oh yeah, we do need it because we didn't do it in our while loop, right? But we could have. Okay, so we've got this lowercase response. But what we're concerned about here is this secret login function. Remember, we passed in the first name and the last name. Now, in our secret login function, it says whatever thing was passed first and whatever thing was passed second were both passed by reference. So within this function, we could potentially update those first and last name values. All right. Now we go ahead and declare a couple string variables. And we use this temp variable to hold part 1 of the name. And then we set part 1 to the lowercase version of part 2 and add a couple of stars. So then we take part 2 and say, I'm going to convert whatever I saved in this temp variable to lowercase to become part 2. So what do we do right there? We swapped. We did a swap of variable data. We used a temporary variable to hold part 1, changed it, and then used our temporary variable to hold part 2. So now we have our first and our last name swapped, and in our last name we have some stars added. Then we make their login be that combination. So it should end up being like last name star star first name. And we tell them that's their secret login. So here it is. Your secret login is lamb star star Mary. However, our main method, main function, back up here, when this subprogram gets done, execution continues right after the call, right? So we're going to keep going, and we're going to write out the second message with the member's name. So our member name now is messed up because we updated those variables within that function. So it's not really their name anymore, and it's definitely not first name, last name. So how could we change this thing to make it work? We could take out the as ref syntax that's making it be passed by reference, so that this function runs on its own standalone the way we're used to and doesn't interfere with its calling function. Vincent, no, it doesn't. Python doesn't allow us to do this. So within Python, if we were passing a list or an array, it will automatically make it an as reference type variable. Because think about it, if we had an array with 1 million entries, we don't want the system to necessarily make a copy of that every time we use it in a function. So most programming languages automatically pass arrays as reference, but it won't let us say that we want to pass variables that way. It's like, nope, nope, don't like it, won't let us. So makes it hard for us to do examples. I've tried to talk a little bit about scope as we've been learning. We saw that our global variables, that are variables that are available to all of our different subprograms, and they're usually declared at the top before the other code. Our local variables are variables that are just declared within the subprogram, and they're local to that subprogrammer module and can only be used in that subprogrammer module. Whether a variable is global or local is referred to as the scope of the variable. The scope being how widely, how far can it be seen. So when we're looking at local variables, the subprogram can change them all at once, but it has no impact on anything outside of the subprogram. And they can be separate. So I could have variables with the same name in 2 different functions, but they would not be related because they each have their own local version of those variables. This example uses both local and global variables. Looking at it in pseudocode, they start out with my number, and then within the subroutine, they add your number. So the your number variable is only available within the subprogram. And the pseudocode is kind of assuming that anything that's declared up here at the very top of the main is global. We know for Python it would have to be declared, outside of that at the very top. In this program, our main method would not be able to write out your number, because your number is only available within this subprogram. What, Isaiah? You wish you knew about passing by reference? So in this example, we have a variable named count, and we just want to reinforce this concept that even though we're using the same variable name, they are referring to two separate locations in memory. So they are different variables. In this example, our main method declares a name that's a string, and then how many employees and count is integers. They ask, how many employees do you have? We read that in. We start a for loop. Now remember, this is pseudocode syntax for a for loop. So it's different than what we use in Python, right? In Python, we don't have to have these semicolons. And I won't ask you for pseudocode anymore, but if I were to, I would not require you to have this kind of for loop syntax. You could write your for loop however you wanted so that you could communicate what's going on there. So this is just a syntax that they've supplied for our pseudocode. And if you read it, what they're saying is start a for loop using a variable named count, start out with it at 1, as long as it's less than the number of employees, keep running the loop and add to count. So in our Python loop, we would be supplying the same type of information, right? But it would be just formatted a little different, just our different syntax. So we know what we want to do, we just got to find the right syntax, right? And within our loop, we'd ask for each employee's name. So we're going to run this loop over and over until we've run it for all of the employees. Now Isaiah says he had no idea what passing by reference was. Yeah, and it can really mess you up. Plus, if you want to pass by reference because you want something to be updated, that can be hard to accomplish also. Vincent, yes, like what we've been doing, that's correct. That's the right Python syntax. This book is just using this kind of C Java-like for loop syntax for our pseudocode. So it's kind of confusing because the Python syntax is a little bit clearer. You could use Python, it's fine. Okay, what is the purpose of the plus plus? Yes, Chelsea, it is just like the plus equal. Good question. So what that means, and again, it's used in programming languages like C# and Java, that plus plus just means to add 1 after this is at the end of this statement. So every time it runs this for loop, it'll add 1 to count. So it's just like the for loops we did in Python. We just didn't have to tell Python to update the name of our count. It took care of it for us automatically. Does that make sense? But yes, it's a shorthand, add 1 to count. So we could also see count minus minus, which would subtract 1 from count if we wanted it to go backwards. Okay, so our loop here is being controlled by this variable named count. It's really important to our loop, right? If we messed up our count variable, we could go into an infinite loop or cause some other sort of problem where things aren't working right. So we want to make sure that our count variable is maintained. Within our for loop, we're calling this function pay employee. In our pay employee function, we declare a count, and we use it for another loop, and we write out their hours worked 7 times for each, once for each day. And then we tell them what their total pay for the week is. So we're just kind of in a loop adding their new hours to their current hours. What's interesting here is that this count variable is completely separate. So as a beginning programmer, it can be really easy to think that the count is getting messed up in this subprogram because it's using the same variable name. But if you notice, they're just completely separate. The main method declares count as an integer, and our function declares count as an integer. So it's just a completely separate thing. Let's write this one real quick so that we can put it in Python, because these for loops are so ugly. I'd like you to see the equivalent in Python. I'm going to try to bring Atom up. And if you don't have Atom running, that's fine. Just bring up idle, anything that you can use to code. I think we have most everybody working, but we still have a few issues here and there. I'm going to create a new file. And I'm going to name it Chapter 9. Let's call it count loop, just so that we can kind of remember that it's the one that goes with our example. Now I'm not going to set up the teletype connection thing for now, because we're just going to code this one. So see if we can. I can get it just a little bit. There we go. So I'm going to my idle just seems to have lost my color coding for Python. I must have disabled some sort of add-on or something. So I'll try to forge ahead. This script is, what should we call it? They call it like pay employee or something. Chapter 9. I might have to switch to idle because I might not be able to code it without any color coding. I'll be like, what? Now this one is kind of messy for testing, because we don't really want, to have like 500 employees or anything. We'd be here forever. So we'll just try to get the same impact going. Now, because we're doing Python, we're going to kind of do it backwards, right? We're going to start with our pay employee function. And our pay employee function is going to need to have input a string named emp name. Let me see if I rename this and put my .py on it. Will that fix it? Oh yeah, much better. I was like, I can't do it. Now you can see it, because it was just all getting so ugly. And that's one nice thing about Atom. I can zoom in, which I really couldn't do very well with idle. One other thing. Oh, RJ, thank you. I wasn't even looking over here at my comments. Oh, and Michael said down at the bottom of Atom, could change it from plain text to Python. Ooh, awesome. I didn't know that was there. Very cool. So keep telling us those things about Atom. Very nice. Now, as I'm writing this function, I'm using the naming that they use. Notice it's different than what I've been using normally for our Python programs. We don't use uppercase to begin our function names and our variable names normally in Python. But since they do in the example, we'll do the same thing here. We want a rate, hours, And the last thing is pay. I'm setting each of these equal to 0.0 because we want float values, not integers. This example is a really good example of doing a sum in a loop. Why would we need to do that? Well, think about processing for, like a checking account. You're going to read in all of the debit card transactions for that account in a loop. Is there a transaction? Yes, read it. Subtract that amount from their balance. Is there a transaction? Read it. Subtract it from their balance. So this kind of processing is really common in our field, that we do a lot of summing in loops and counting in loops. I want my count integer, and we'll set it to 1, but we're going to use it within our for loop. So we'll get that all set up. See, they set sum to 0. We already have that. So we're going to input. We need to read in see an error in our pay employee function. They said that the name is going to be called emp name, and in this write statement they're using name instead of emp name. So we'll fix that. So we're asking for the rate, and we're going to have to make it into a float. And our prompt should say, enter the pay rate for name. So this is from our write statement and our input rate. We've been able to combine those two statements into one for Python. Next, we want to create the for loop. So we want to start at 1, and we want to execute our loop body once for each day of the week, or 7 times. So how can we set up our for loop in Python to do that? What do you think? Any suggestions? I've got my for part. So can I use my count variable? We want our range to be 1, 2, 7. So we'll have to put 8 is our ending point. And we want to add 1 for each time. So we don't need anything else in our for loop. Does that look right? To run that 7 times? So it should start with our count variable 1 and run it 7 times. We'll test it. Now within that loop, we're going to prompt for the hours they worked for this day. So our hours variable, we're going to use the input statement, and we want to convert the data to float. Enter hours worked for day. And then after the word day, we want to add the value of our count variable. So we should have day 1, day 2, day 3. once they give us that information, we want to add those hours to our sum variable. So our sum variable is going to end up being the number of hours they worked for the week. So we have to use the variable name on both sides of our equal sign, right? Our answer, our result is going to be saved in our sum variable, but the equation is using your sum variable, add the hours. So that looks good. We're going to prompt for each day of the week, how many hours did they work? We're adding those hours to our sum, and then we'll end our loop. And then we want to update our pay variable. Okay, so I'm going to end the loop by doing back tab, and I want to update my pay variable now. We're going to use that sum of hours that we were calculating and multiply it by their pay rate. And then finally we'll print out gross pay this week for temp name is I think they want a $sign too here. Then said the third argument, the increment is optional, right? So it's going to default to 1. So we should be okay. Okay, I think that looks good. What do you think? Other than maybe that our range statement could require the increment amount. I'd like to test this function. So I'm going to kind of create a tester. Frog tester. Not really. Of course, they have their main named with an uppercase M also. That's all right. So in our name, we need to prompt for the name. Well, I'm sounding very mean and angry with all of the uppercase letters. I'll just make that first one uppercase. So I'm going to prompt for the name, and they want some other stuff. We'll put that in. Let's just call this. We're going to call our pay employee, and we're going to pass our name. Execute our main, and let's see how if it works. Try it. Just reading the chat messages. Good job. Oop. Uppercase. All right. Here's Tom. Okay, Tom makes 15. I need a space there. Need a space there. Let's see, some days, how much is he working? We're going to say he works 4 hours a day. And he did not work on day 6 and 7. So looks good. So it seemed to work okay. Let's fix up some of that spacing. Enter the pay rate or enter hours worked for a day. I'll have a space there. I do not there. It's not quite formatting it the same, huh? Okay, enter the pay rate for Tom. And see, I've got a space there. Oh, it's after, isn't it? It's like, I've got a space. We need a space after that variable. Is that the same thing for our hours? Sure is. We've got a variable here at the end of our string that we're using as our prompt. So we have to get right in there in the right parenthesis. We want to leave one closing parenthesis before we do plus a space. And then we should have two closing parentheses after. See if that looks better. $10. Looks much better. I might not want a space before the dollar sign, but I could mess with that. So everything looks like it's working pretty well. If we go ahead and add the loop to our main, let's see if we are going to mess up our pay employee function. In our main, what they would like is for us to prompt how many employees do you have. I need to put that before this stuff. Let's see, they call that non-employees. And of course, we want to make that into a float. So I will wrap that with a float function. So that float is a function, right? A system function. So now we're reading in how many employees. And based on how many employees they have is how many times we want to run a loop to call our employee pay function. So for in range and we have to add one to the number of employees since our for loop in Python runs until we get to that ending value. Now we've got that in a loop. So my main is running a for loop that's controlled by a variable named count, and our pay employee function is in a loop that's run by a variable named count. Are they going to mess each other up? They shouldn't. They have differing scope. Let's say I have 2 employees. Crash. It says, why are you trying to interpret this as an integer? So let's make it an integer, not a float. Using it in our for loop, it needs to be an integer. 2 employees. Now our first employee is Tom. He gets $10 an hour. And he works 5 hours a day, 5 days a week. So his pay is $2.50. Bill makes $15 an hour. And he works the same number of hours. So his pay is $3.75. So everything working. Notice our loops are not affecting each other. They're completely separate because of our variable scope. Now, we could have all of this code within this for loop, right? We could make them nested loops. But notice how by separating this information out into a separate function, we make our code much cleaner and easier to understand, because now we can just focus on specific things for the work at hand. We don't have to be, wondering, what is all this code, because it would make it very stretched out. So separating everything out into functions makes it much easier to maintain. I can't have both go slower and raise hand on at the same time. You're fine, Vincent. I'll just leave it here on the screen for a minute. Just let me know. That's a good way to let me know, because I'm typing and it's hard to look at all the places. You guys just yell. You can turn your mic on too. Sometimes that would be the easiest way to get my attention. I'm just going to leave this sit here for a sec until I see some thumbs up. Vincent still got his hand raised. I'm making him crazy here. How's everybody else doing?
There is an error I need help fixing.
Oh, okay. You want to show us? Let me stop the share. All righty, show us what you got. Huh.
Is it possible that sum is a taken word in Python?
I'm
Like
not
a
getting
reserved?
I'm not getting any sort of highlighting like that. Try running it again.
It won't run.
No matter what you do. Invalid. Oh, okay. So is there something above it? Let's look above it. Are we missing a closing parenthesis maybe? 1, 2,
Yes.
3, 1, 2. Yeah. So put one more closing parenthesis. So even Adam can't tell that there's an error there on that line above. That's too bad. It's a long day. Okay. Or is it crashing now?
Now it seems to work.
Are you good? It looks good. RJ, can you show everybody again? And we'll review that, because I imagine they caught some other people there too. Oh, so our problem in the main on the input, how many employees, we need to know down in our main Yeah, we want the num employees to be an integer, not a float. So where we're inputting the number of employees, nope, the code we already have. Sure, you can interrupt, Vincent, that's fine. Make that int instead of float. Yeah, you guys can interrupt anytime with your mics because it's so quiet. Now see if that'll work better. Always getting all floaty with stuff. Where are we? Oh, for how many employees answer with a number instead of Billy. Beautiful. Looks good. Yay. Anybody else having trouble? Looks great. Now, some things that just have to do with programming style. I mentioned how we could have just had this as a nested loop. Some companies that I've worked for in the past actually recommended that if you were going to code a nested loop, you should break that out into a separate function, just because over the years they'd found that things were so much more maintainable that way. So we'll see some people that, you know, aren't really comfortable with the idea of subprograms or functions, but it's something that's really, really important to us as developers. So we want to keep working on it. Beautiful. So functions that we have from the system, built-in functions. Most programming languages, like I say, offer these. There's a function usually to find a square root, to convert something to an integer, which we just used. The ceiling function is interesting. It actually does round a number up to the next integer. Floor just chops off the decimal place to make a float into an integer. So notice the difference there. Ceiling will do rounding, floor will not. It just chops off the decimal. Random, go ahead.
So floor is identical to int?
Yeah. I'm looking at it like, there should be a difference. No, they're exactly the same. Pretty much the same. I think that's why it took me a couple years to remember what floor did, because it seems really irrelevant, but I'm sure it's important in some way. We might not have all of these functions available, but Python pretty much does. Now random, we know gives us a random number. The length of computes the length of a string, and we've used that in Python for our name plaque. And then 2 upper and 2 lower, we just were talking about earlier. So most programming languages have them. We've seen str converts something to a string. Some languages have an actual round function that would be the same as the ceiling function. Some don't. So you're going to find languages that have some of these and not necessarily all of them. ABS is an absolute value. So that just means it eliminates the sign. So if a number's negative, it would eliminate that negative sign.
Actually, I think I do know the difference between floor and int.
What is it?
One chops off the decimal place and the other rounds down. So if the number is negative, it would round down and the other one would round up.
No, neither one of them will round up.
Really?
Never.
Floor won't go down if your number is negative?
It will always just chop off the decimal place.
All right then.
We'll try it. Let's try it. We'll write a program and see what it does. I think we should try using some of these. Here they give us some examples. Let's try some. Get situated here a little bit. So I want to create a new file for this. You guys help me make it be an actual Python file. So this is going to be chapter 9, ifs.py. So a BIF is a built-in function. Unless you've been watching Back to the Futures. Right? Saw something about it the other day. So built-in functions. Okay, so let's print ABS of 10, and then we're going to add, oh, I need a space there. We'll add ABS of 10. Noticing that that turned blue, it appears that ABS would be the correct name for the Python absolute value function. Does that seem correct? Let's try running it and see, because if you notice, I haven't created any functions or anything here. I just put this print code in. Must be str, not in. So I have to convert it to a string still, but I could be kind of lazy and I'll change my concatenation character to a comma. And Python allows us to concatenate both ways. When we use the comma, it will be able to handle adding that number to our output without converting it to a string, because I just don't want to complicate up our function calls. Okay, so it says the absolute value of 10 is 10. Now let's do the same thing for minus 10. Same result, because it just eliminates the sign. Okay, let's try rounding. So for our rounding, let's try, what, 10.2? And let's try RND. Looks like that's a valid name, 10.2. I'm going to run that. I think that before I do, though, I'll put another print statement in, just as kind of a border, just a blank line. Oh, it does not like RND. So what should we do? We should go to the web, right? Let's go.
You need to use the whole word instead of abbreviating it.
Do
I was
I?
thinking that's probably it, but
Well, let's check.
I've never seen round abbreviated as RND before.
Python round. They want it spelled out, it looks like. Let's change our info line there too. Is that one better? We can't really tell because, I mean, it just truncated it because the number was and that was correct. So now let's try one that should get rounded up. Whoops. I don't know what I did there. Put that back. So the second time, let's do 10.5. And we should round up. We didn't. What about 10.6? Interesting.
So wait a second, 10.5 doesn't round up in Python?
Not,
That's really weird.
isn't it? So that's why it's so important for us to do, you know, minimal tests like this with a programming language, especially if we're at work and we're going to use one that we hadn't really had a lot of experience with. You know, it's okay to try some things. Well, so that's our round function. Let's try some of the others because that's sure interesting. STR, we don't need to try that one. You guys have used it a bunch, I think. We were interested in the floor and ceiling ones. So let's try those. So I'm just going to copy those two lines and change round to floor because we want to try the floor function. I broke it. Floor is not defined. Back to Google. Can you tell what we need to do? Someone's talking.
No, I can't.
Import math function, like import math library and use math.floor.
Yep. Oh, April says 10.51 rounds up. That's super interesting. Okay, so we want to import math. So we have a floor function, but it's within the math library. So in our floor function, it just truncated both of those like we had done an int function. So we want to try negative numbers.
I mean, I would.
Let's try it. I think it's a great idea. We'll make them all negative and see. So just changing everything to be negative numbers.
I was right.
Look at you go. Good job. So yeah, it is not what I would have expected. So really good. How about ceiling then? I'm going to copy both of these sets. And I'm going to select that data. And I want to see, can I do a replace, edit? Where's like a, let's try replace in buffer. So what I want to find is floor, and I want to replace it to ceiling. Now, I only want these ones that I have selected And it seems like it's found all of them. It's gonna change everything in my file, which I might want sometimes, but I don't want that right now. So what I'm gonna do is do a find. Now I don't want to replace that one. Keep finding. And then I'm gonna finally replace the ones that I do want to change.
You don't need to type the whole ceiling word. You just need to type seal.
Oh, okay. So now I want to change the whole word ceiling to seal, and it's in the math library too. Did you find it? Now this time I can replace all. And RJ saying Control F to do that find. If you bring up the Control F find, does it give you the replace option? Handy. On Windows it doesn't. So. Or just, you know, new different versions. Let's say try ceiling. I'll let you look at those results. Pretty interesting. Okay, so this little code snippet is pretty good because it tells us what the function names are for a lot of those built-in functions. We found them in Python. We know that floor and ceiling are in the math library. Round and ABS are just in the standard system library. We're able to call them directly. So this is a good example for you because it kind of has all of our function calls together. One cool thing we can do in Atom, or that I think that is neat, is if you go up to your tab and right click, you can split your screen a bunch of different ways. So if I wanted to see this code side by side with that count program we just did, I could split left, and then I could go to my count tab. And so I can have all sorts of things side by side in Atom. I can drive you guys crazy. I could also split left, split right. So depending on where I want to go, I'll close these back out. Then I can close this tab, or I can close other tabs, and so I can have all sorts of great things working. Make this full screen so it's not quite so hard to see, so you can see it. So Atom does give us some neat capabilities to be able to look at, you know, one source code file while we're creating another. Copy things over, great things like that. Okay, so using our built-in functions, you guys have been using them all along, but it's nice to know exactly what's going on. When do we use a function? I've mentioned it quite a bit. Anytime we need to separate out some logical code. Anytime there's a logical function, we should implement it as a separate function. This discussion that our text is getting into has to do with some older programming languages. In some older programming languages, we had two different types of subprograms. We had functions and we had subroutines. And they could both be used in any one program. So sometimes it was hard for people to know, should I use a subroutine or should I use a function? Well, the big difference between them was a subroutine does not return a value. So all of the functions we've created so far would have been considered subroutines in those old programming languages. A function is considered to be something that actually returns a value. So let's look at all of these function calls. Do these functions return values? Yup. The value they returned is what we printed out, right? So we called the function, passing in an argument value. It returned a value to us that was displayed on our print statement. So these old programming languages that had subroutines and functions, sometimes it would be hard for programmers. They would be like, oh, what should it be a function? Should it be a subroutine? So as languages have evolved, we've eliminated that kind of confusion. And in Python, we just call all subprograms functions. So whether it returns a value or whether it does not return a value, it's still a function in Python. So you might see some confusing narratives like this once in a while, because our textbook is trying to cover the gamut for all programming languages ever. And some of them, thank goodness, are obsolete and you won't see them much anymore. Okay, we've got an example here. And in our example, we're going to calculate the miles per gallon for some different trips. And we're going to output kind of an array. So I want to skip this one because we didn't really process our arrays section. So that one could be a little bit too hard for us right now since we skipped a couple of chapters. So skip that stuff. The last thing in our chapter, I think, is the concept of recursion. And a recursive subprogram or function is one that calls itself. Some programming languages won't let us do that. So it could be hard to implement recursion in some languages. And I'll show you why some of them don't let us do that. Sometimes recursion can be a really effective way to solve a problem. The example that they give us here is where we have a number, say 5, and we want to calculate what the sum is of that number plus all of the numbers down to 0 that are less than that number. So they give us this formula. That sum can be calculated by starting out with a number that's 1 less and adding it to the number. Well, we'd have to keep doing that until we got down to 0. So in some sort of loop, we could say, you know, set up this sum variable, add n-1 to it. But in this example, we're looking at doing it in a recursive way. And in a recursive way, we're saying that within the sum function, we're actually going to call the sum function again. So we can make it call itself. It's kind of a weird way of doing things. And RJ has pointed out to me that, is it question 10 in the short answers? You really don't quite have enough information for that one. So look at that question, but everybody will get credit for it. Now, in our textbook, they talk a whole lot about this recursion. And I think it might be easier if we just look at an example. So I'm going to bring this one up. This is a recursive program, and it's basically the one that they give us in the textbook. So I'm going to give you a minute to copy that. Actually, I can just post it. I could put it in the chat. I'm going to send it in the chat. I don't think it'll be too messed up. I swear somewhere on Zoom I saw something about sharing a code snippet, but I do not see it again. Maybe I was someplace else. Okay, do you see that code? So this is kind of what they present to us in the chapter. They say that we have a number n, and we want to find out what the sum is of n plus all of the numbers that are less than n down to 0. So we've got the same formula here as they have in the textbook, that our answer is going to be equal to sum of n minus 1 plus our original n. In our sum function, we check to see if the number that was passed to us is 1, meaning if we've kind of reached the end of the numbers. And if it is, we exit our function. Otherwise, we do a recursive call to ourselves to call sum again. Now, one place that you can visualize recursion pretty easily is in File Explorer. I'll bring up File Explorer. I don't have enough windows of it open yet. In File Explorer, I start out by double-clicking on something like my C drive. And I start with this folder list. Now, I can go into one of the folders, the Windows folders, and I'll see another list of folders. I can go into the folder that I want to see, and I'll see another list. So every time I double click on a new folder, it's basically a recursive call. List the files, list the files, list the files. And then I can back out of that because Windows has kept track with the breadcrumbs of where I've gone. We can kind of do the same thing with this one. We'll keep track of where we've gone. Okay, I want to use, I'll run it, make sure it runs before I copy. Yeah, 5, the sum of 5 and all the numbers below it is 15. So I'd like to go to that visualize website and run this. So I'm going to click edit this code. And I'm going to change to the recursive program. I'm going to click visualize execution. Let it read through my data, and it's ready to start executing. It knows we have a sum function that requires a parameter. We're going to name that num. Line 10 begins our calculation, beginning our recursive call. So we're going to call sum for the first time. So I'm going to go ahead and run that line of code. Now, here is our sum module running. The number that was passed to it was n minus 1, so 5 minus 1, or 4. So our sum function here is running for the number 4. So as we begin executing our sum function, our number is not 1. So we're going to do the recursive call to call sum again with a new number, which will be our current number minus 1. So now I have the sum function in memory 2 times. One time when it was called with the number 4, one time when it was called with the number 3. As I execute the sum function again from this recursive call, num is not 1. So again, it's going to be called recursively again with a parameter of whatever the number currently is, minus 1. So now we have another instance of our sum function running, but our num variable is equal to. One more, let me keep going. It's still not 1. So I've got to make one more recursive call. This time, n minus 1 is 1. So this is going to end our process. Let's watch it end. In our sum function, we say, is num 1? Yep, it is. So I'm going to return a value of 1. When I return that value, my function that was executing for the number of 2 is going to receive it here in this line of code. So a return value of 1 is going to be replaced right here. And we're going to end up with a formula that says 2 plus 1. Return the 1. Now, in our call to sum for the number value of 2, we're returning the current number, which was 2, plus that number that we got from our lower recursive call. So this time we'll be returning the number 3. Now we only have 2 instances of our sum function still running. This sum function is the version that was called with the number 3. So in our return statement, we end up with return 3 plus 6. When we click next, we return to the last instance of our sum function that is still running. And the value that was returned to us this time was 10. We started with 4, so we'll add those 2 together and end up returning that value to our calling program. Let me do previous because that one. So when we are done here, we return that value of 10. Now our answer can be completed. We were already executing this line of code. We've been waiting for this return value from all of these executions of sum. We're going to see it now. Finally, it's going to be 10. So answer is going to be equal to 10 plus 5. And then we'll see that print out. So a recursive function is simply a function that calls itself. For this application, we could have used some sort of loop, right, to calculate this sum. Which one would have been better? The loop. The loop is easier to understand. The loop requires less resources. This recursive function, if you remember, had itself in memory 4 different times before it finally started returning back so that it could release those resources. If I have a recursive function like that that runs 1,000 times, how many times is it going to be stored in memory? 1,000 times. So it can be very, very resource intensive to run recursive modules. Sometimes it's the best way to do things. So the definition of recursion is a function that calls itself. When it executes, it can be a little tricky to follow to see what's going on. Questions about that? I think that is the rest of it. All right. We didn't get a chance to use Atom at all, really, to speak of. Hopefully, the majority of you had it installed enough that you were able to use it for the code that we did write today. But we will try to do the teletyping thing and give everybody a chance to work on it. The assignment, remember, that you have that's due next week for calculating all of those different I think I have it open somewhere, but I just have too many windows. Can you find it? There it is. The display area program. On your rubric for general programming, there is an area that says that the proper concepts were utilized in the program. So when you're looking at that, we really should see some functions in that one. You know, there should be some functions defined. Up until now, I've always said, oh, that's okay. You can do it all just, you know, top-down code, or you can do functions if you want. But for that one, it would be best if you had functions, so there will be a minor deduction if you have no functions there. But that's what we needed to look at this week, and I think that we have a lot to mess up. Only that looks nothing like the test. What are you seeing on the test? What's it doing to you?
It's mostly what RJ was talking about. The question is so compressed in regards to recursion that it's almost impossible to understand.
Yeah, that one, they just did not give you enough information. Yeah, that question is just awful. So I should have deleted it out of the required questions after last semester when we realized that it just, you know, because last semester or the semester before, really recently we had a new version of this textbook. And so I should have deleted that last semester when it caused trouble, and I did not get it deleted. So it is not you. And RJ and I were talking about it yesterday. An important thing to kind of pick up from that is sometimes you can be smarter than the book. Sometimes you can realize it's not giving you enough information, and you know, might be right. There's always a chance we could be missing something, but I feel like it's not giving you enough information to answer the question. They just, I don't know what they're implying there. I haven't referred it to the publisher, and I should. So that's question number 10. It's not you, it's the question. There's something wrong with it. I'll at least update our form to say that. Any other questions or comments? Still can't figure out where impaired program answers to the review questions are. Oh, Vincent, they're just in the chapter. You have to read them. It doesn't give you the answers anywhere. Just have to go find them. I know RJ lost brain cells on that question. I have several times because I still keep trying to figure it out. What are you looking for? Which, is there a certain one in particular? I'll bring up the book. Three, 4, and 5. Let's take a look. So a diagram that shows the data transmitted between program modules. If I look at that one, is like on the very first page of our chapter. A chart that shows the data that is imported to, processed by, and exported from each program module. And then 5, the part of the program in which a given variable can be referenced is called, yeah, what is that one? I mentioned it a few times today too. RJ's giving you page numbers. He is so good. I'm going to go up to the beginning of the chapter and show you. So here we go. And it says that it keeps track of the data. So it doesn't really come out and say it exactly like the question, like it did in the early chapters, does it? So you have to kind of like imply. So that's the data flow diagram that they're looking for. And then I'll let you look at the one on 593 because I've mentioned it a few times already. just reach out anytime with that. And don't forget, on Discord is a great place for those kind of questions. Anytime, Vincent, you can just jump in there and ask, say, I can't find this, where is it? And I like that RJ is giving you page numbers so you can go look instead of just saying, well, it's a data flow diagram, because it's so much better if we go look instead of just getting the answer. Anything else? Nada, you guys are doing great. Let me know if you run into any problems. The people that are still having trouble with Adam, do let me know and we
I
can
still need to figure out how to change the push to talk key.
do what?
Because it's, right now I have it on the default space. But when I try to hold it in talk and it's focused on chat, it puts a bunch of spaces in chat instead.
In your code?
Yes.
Okay, well, you'll have to get with me on that one offline because I'm not sure what options I would need to change.
Yeah, you just got to click on the Zoom window, I think, and then you.
Vincent or me?
The only thing I see related to push to talk is press and hold space to temporarily unmute yourself.
Is
Right.
I don't know how to change that key.
Oh, I don't know if you can. If you go to your Zoom settings, let's see if we can find it. On this screen, if you look at home, do you have this settings icon here? And it's only on this home screen. And I don't know, you guys are going to have different settings than me. But down here are the keyboard shortcuts. But it doesn't look like it lets you change them. So if anybody sees anything, post it to Discord. What Vincent's talking about is if you leave yourself muted, if you hold the space bar, you're supposed to be able to talk, you know, without actually unmuting. And if it's putting a bunch of spaces in your code, that's not good. So let's see if we can find something there. Because here it says press and hold space key to temporarily unmute yourself. And I don't see any place that you can change that to not be the space key. So we'll figure out some of those things, keep bringing them up so that we can find them and get them fixed, because that's no good. Anything else? My to-do list has exceeded my size of paper. So I hope yours is not the same. All righty, I'm gonna keep messing with Adam and try to get everything all set up for the people that are still having some issues. Find a easier, better way to do it, because it seems like we had a lot of work to do for that. But other than that, I hope everybody has a great weekend. Let me know if you run into any issues. Bye.
All right, you too.
Thanks.
Goodbye.
Bye. Bye-bye.